Welcome to Walkabout the Galaxy, the flexible astronomy podcast where the science is universal, the opinions are personal, and the attitude is casual. We are Strange and Down, the astroquarks, also known as Josh Caldwell,
And Audrey Martin.
coming to you from the virtual Walkabout studio with a special duo quark Walkabout mini episode this week, while both Charm and Top Quarks Addie Dove and Jim Cooney are on special assignment. Be sure to follow us on Instagram and anywhere else we may happen to show up, which is probably mainly going to be Instagram. Catch our videos on YouTube. We are at Walkabout the Galaxy. You can also contact us at wtg@ucf.edu. So Audrey, as you know, usually I have a stumper,
Hmm.
and usually you're pretty stumped
I
because it has
am,
something to
yeah,
do with like science fiction or space stuff that you don't know about.
yeah, yeah.
So I have a quick mini stumper for you.
Okay,
Okay. Luke Skywalker,
I've heard of him.
Gan Gandalf,
Okay,
or Spock.
uh-huh.
That's the stumper.
Well, just okay. Pick one. Gandalf, easy. Not
Okay.
stump, not stumper
Not
at all.
stumped. Yeah.
Even
Okay.
I
Why
think
though?
even if I knew, I mean, maybe Spock would be like kind of cool to pick in
Yeah.
any scenario, but
Right.
Gandalf is magic. Gandalf
True.
has magic, so super knowledgeable, knows magic, seems like a pretty chill guy slash wizard.
Might be more fun to have dinner with
Definitely.
Gandalf than Spock would.
Yeah. Have he might have cooler stories and be able to tell them in a good way.
Right. Although if Spock came with all of his like tricorders and things like that, then maybe different. But okay. Anyway, that was
Yeah.
a super mini quick
Well, what's
stumper
which
just for
for
you.
you?
I
Oh,
have to go with Spock.
okay.
Yeah,
That's fine.
because Spock is a real person, unlike Gandalf or Luke Skywalker, who is in our future.
Oh, okay. Isn't Luke Skywalker in the future?
No, oh my gosh, Audrey. That's a,
Did
a
I just
long
did
time
I?
ago in a galaxy far, far away.
Oh no, the first like
The
five
very first
seconds.
thing that you learn about anything in Star Wars is that it's a long time ago in a galaxy far, far away, where Star Trek
Well,
is our future. And Middle
we
Earth, I don't know
already,
what the
yeah,
heck that is.
it's parallel
Parallel,
or
some
something.
ancient
Yeah,
parallel universe. Okay.
yeah.
Well, today we'll talk about Saturn's first Trojan, but first, this episode of Walkabout the Galaxy is brought to you by vibrational states. When the phone won't
Hmm.
stop ringing and the emails don't stop pinging and the kids don't stop clamoring and the demands for your attention just won't stop, maybe it's time for you to try vibrational states. Neatly organizing all your nervous energy into discrete quantized levels, vibrational states let you ignore the extraneous inputs of everyday life and concentrate only on the inputs that are relevant to you. Powered by quantum mechanics, vibrational states will allow you to quickly sort through the clamor and commotion around you and interact only with the energies that match your particular needs. Mention Walkabout the Galaxy when you order vibrational states for a special 30% offer off on rotational states. Vibrational states, instant gratification, permanent pleasure.
Uh, um,
Maybe you don't want to
uh,
guess.
Haagen Dazs.
It's more in the sort of vibrational realm.
Uh,
So
uh,
we're just gonna say it's Lilo, a Swedish manufacturing company, and leave it at that.
or a phone that can vibrate and then you're answering it, hello, and then also it stores your pictures long term.
If I were a more appropriate person, maybe I would have chosen Apple or Google or something like that because of that line of reasoning. Uh, Space news, we're tired of mentioning all the Starlink satellites going up, and it's just
There's
kind of
just a
like whatever.
million.
There's a million of them, and they keep going
Yeah,
up. They
millions
used to
and
be launching
millions.
like 40 or 60 at a time, but these days they're bigger, so they only launch like 22 at a time, and
That's still
presumably
so
they're,
many.
oh, I know, yeah, it's crazy, crazy numbers.
Yeah.
Um, and there was speaking of SpaceX, they had a Crew Dragon return with four crew members from the International Space Station recently,
Oh,
and that was
including the
no,
oh
not
oh
those. Yeah, those two. Their
they're
ride
still
is
up there.
there. Their ride is up there, but they're the next group to come down. I get, or I don't know
Oh,
if they're the
okay.
next one, but they're still up there for another few months actually. So
Oh
they
wow,
kind of
cool.
took the place of a rotation that just went up of two people that would have launched with this last
Okay,
group.
I
So
remember that now.
yeah,
Yeah.
yeah.
Oh
So
man.
yeah, well, they get they get more adventures in space and more cool things to observe and do, and a little bit more disintegration of their bones and things like that that happen in
All
low gravity.
pluses. Everything, all good things. Who doesn't
Everything is
love a
all
little
positive.
bone disintegration every once in a while?
Every once in a while, you don't want to overdo it. You
Right.
know, it's like
No.
everything in moderation.
Few months
Yeah,
though. Great.
right. Other space news. So what's been, gosh, it's been maybe a couple weeks ago now that again, SpaceX, they had the successful integrated flight test 5 of the
The
Super Heavy
chopsticks.
and the chopsticks grabbing, which was very science fictiony, very cool. My, you know, it's hard. That first stage is huge. It's 70 meters tall.
That's
It's like a 20-story building um,
ridiculous.
that
That's
that came
ridiculous.
down, and then it lands. There's two like pins on the side of the rocket at the top that land on the chopsticks, and so it's not just like
Oh.
you know getting in between the chopsticks and at the right position in between them. It has to have the right rotational orientation as well. Like those two
Right,
things
yeah.
has to be exactly lined up. It's not like it's got a ring and it could come in any which way or whatever. Um, so
Oh, so it's just
obviously
like these two little things that have to like
it's
slot
this, yeah,
right,
I mean, they're
or just like,
structurally very solid, but it's just like two
I mean, I
points.
assume.
It's 2 points that it is suspended from.
That makes
So,
a little bit more sense than what I originally was thinking, though, because I imagine that the 2 points also carry some of the weight. And it's not, because in my head, it's the chopstick and it's like catching it, and
oh, it's
then
like
that's
squeezing
holding the,
it.
yeah.
Oh, yeah, not at all. Not at all. So the
Okay, well, that makes
chopsticks,
a little bit more sense that
it
it's like
has some
resting
has
on
some
it.
has some bumpers, on the side
Yeah, okay.
that it comes in, but the weight is supported vertically entirely and not by
Okay.
like pinching it like you do with actual chopsticks.
But yeah, that makes it even harder because it has to like there's a I mean I assumed there was a specific spot that it was going to like squeeze it in, but like yeah, there's a specific spot that it has to like close and then get down to. But if it closes too
Right.
fast, I imagine that the thrusters would mess things up or
Well, it
something.
was like you could see those chopsticks like maneuvering a little bit. It's like coming in and then back, because I assume that from what I see, there's communication going back and forth between the rocket and the Mechazilla apparatus to interactively adjust things during the actual catch. But like if you rotated that, if you rotated the rocket by 30 degrees or maybe even 10
Oh
degrees,
yeah.
it's not landing, right? It
Yeah.
has to be
Yeah.
rotationally in every different orientation that you can imagine has to work out well. So I don't know when the next one will be. There
Oh
was looked like some minor damage on the engine bells, and then there was something that blew out at the base of the rocket. So it'll be very interesting to see what the goals are for Integrated Flight Test 6 if they try to bring the Starship fully orbital and land it and recover it, or if they do anything different with the landing of the Super
yeah.
Heavy.
Oh right.
If they sort of make big changes to what like the flight profile is, they have to get a different launch license because their new plan has to be reviewed and approved. So
Right.
that will be very exciting to see when it happens. So
Woohoo.
in our mini episode format, we have one science topic,
Great.
and this is your topic, Audrey, or
Yeah,
it's near and dear to both our hearts, but I think closer to yours in some way.
I guess so. Yeah, it's a Trojan asteroid, but it's a Saturnian Trojan asteroid, which is unheard of until now, I guess. I mean, I guess people have said Saturnian Trojans, but only in like the context of like there are no Saturnian Trojans. Um,
Or at least none
but yeah,
discovered. Yeah.
yeah, or at least not discovered. And the reason for that is so Trojan asteroids, as I'm sure everybody listening has to know because we talk about them all the time, are they orbit in the Lagrange points of planets, and there's most of the Trojan asteroids that we have in the solar system are in Jupiter's Lagrange points. In these two kind of swarms, one that orbits with Jupiter in front of Jupiter in its orbit, and one in a swarm that orbits behind Jupiter. So it's orbiting with Jupiter around the sun. And the Earth doesn't, the Lagrange points for Earth aren't super stable. And so sometimes people are like, oh, like I found one, blah, blah, blah. But like not really. There's a couple of Mars Trojans that are stable and they're there. And then I think there's like maybe 20 that have been found for Neptune, but there's thought to be a lot more. The reason why people don't think that Saturn is a good spot to look for Trojans is because the Lagrange points are not stable. These are gravitational wells, essentially, that for Saturn are just destabilized by Jupiter. Jupiter's massive.
Jupiter's the big bully in the solar system.
Yeah.
Yeah.
And so anything so for Jupiter, the Trojans that are there are stable over lifetimes of the entire solar system. So they could have been there forever. But for Saturn, apparently that lifetime is only about 1,000 years, which is a super short amount of time. And so they found an object in the area of one of Saturn's Lagrange points. So because it's only gravitationally stable for like about 1,000 years, it can only have been there for at like about 1,000 years or
Or
less.
less, right? Yeah.
Which is strange to think about, like an object really not being stable for very long and us able to like detect it. So maybe there's other ones that are also around that like are just kind of like bopping around. The article says that it's bouncing around the
Yeah.
solar
So,
system.
where does it go? If it's not stable. So, yes, there's a lot there going on. Um, so these Lagrange points are like 60 degrees ahead of or behind the planet that they're associated with.
Hmm.
And then the objects that are in them are not like all sitting at that exact point. They're sort of
Yeah,
circulate around those Lagrange points. You have a kind of a swarm at each one. In the case of Jupiter, as you mentioned, which is the one where we think about Trojan asteroids. And so uh, here's this object that was, I guess, first discovered in 2019. It takes some time to like measure its orbit and understand is it actually, and actually this paper is still in preprint form that says that this
right.
is a Trojan asteroid of Saturn, but says, okay, yeah, we can confirm that this thing is, circulating around one of those Lagrange points for Saturn. So it's unstable. Where does it go and where did it come from, right? So if there's one and it lasts 1,000 years, maybe there are others. We haven't had a chance to see them yet. I mean, they're hard to see
Yeah.
things out there. And then it's also takes some time to figure out what kind of orbit they're on. So these objects probably migrating in, there is probably a centaur, would be my guess. This was an object that came in from the Kuiper Belt, which is the region beyond the orbit of Neptune that includes Pluto,
Hmm.
of a bunch of big icy objects. And Neptune's gravity and other perturbations, including even from outside the solar system, can cause those things to like, oh, they have a close encounter at some point, their orbit, and then they end up moving in amongst the giant planets. And during that time, they're just kind of like bouncing around. We call them centaurs. And then uh, presumably there's some probability that they can get captured into one of these Lagrange orbits around with either Saturn or Uranus or Neptune. And you mentioned that Neptune has a couple of dozen. Actually, that was part B of my trivia for today,
Oh,
which I thought I was going to say, well, Audrey may already know this since she's on the Lucy mission, which is going to explore the Trojan asteroids of Jupiter. Probably pretty up on her Trojan asteroid trivia. So
you never know.
part B of the trivia was going to be which planet after Jupiter has the most known Trojans, and that
It can
is,
still be the trivia and I can just get it right.
I'm giving it to you now. Go ahead. Which
Yes,
which planet after
finally.
Jupiter has the most known Trojans?
After Jupiter, it's Neptune.
You are correct, and it has at least 31, is what I
31
had.
is the current.
Yeah,
Okay.
yeah. And it probably has lots more that they're
Yeah.
just hard to see out there.
Yeah.
So
They're very far
presumably
away.
then these like migrating comets coming through can get temporarily captured into these Trojan asteroid orbits. Then what happens if they get kicked out? What's next for this Saturn Trojan?
Yeah, I don't know. I wonder how Jupiter's like nudging would affect it. I don't know if it would nudge it inward or back out. Um, I don't
Yeah,
really know how that would work. Or like if it depends on how the orbital like configuration is, maybe it could do either. I think it.
I'm sure. Well, I shouldn't say I'm sure, but my guess would be it could go either way, but that there's probably a greater likelihood of one way or the other, which I don't know what it is. And
Yeah.
that's based on some work I did that's not really directly related to this, but it's what's making me guess this way. Years ago, I was looking at um, dust particles that orbit Jupiter backwards. So
Oh,
the Galileo mission discovered your doggy is not convinced by my argument,
I
but
know. He doesn't like dust particles.
the Galileo had a dust detector that discovered some particles that were in orbit around Jupiter but going backwards. And I
Interesting.
um, was able to show that particles, like interplanetary dust particles, can be captured into backwards orbits around Jupiter at the right rate to explain that population of dust particles. And uh,
Oh.
and it turns out that they're sort of more likely to be captured going backwards than forwards. Um, and so that's why I'm kind of thinking that Jupiter probably can kick this thing out and it may end up in an orbit outside of Saturn or an orbit in between Jupiter and Saturn. And there's probably a preference for one or the other, but
Probably.
I don't have the intuition to know which way that would go.
Yeah. I
On
don't
the one
know.
hand, it's tempting to think that I don't know because it's the energy is conserved in the whole system somehow. So
Yeah.
if the comet, or is it a comet type thing? Do we know
I
anything about what
mean,
this is made of?
well, that's I no, I don't think so. I think they have only just gotten the have gotten like the orbital characteristics, which make it okay, cool. We know where it is. We know its
Uh-huh.
orbit, and it's in the Trojan region for or the Lagrange region for Saturn. And
Right.
then follow-up observations are going to be done to
Okay.
determine
So,
like the type and the color and like all of that stuff. So we don't know if it's icy, we don't know if it's rocky or
okay.
anything like that yet.
Okay. Well, that'd be certainly very interesting to find out, like, because that'll tell us if it's, freshly delivered from the outer solar system or
Yeah.
something like that. Yeah.
Yeah, it could be like actively sublimating
Right.
or who knows.
Yeah. So whenever if Jupiter's a bully and kicks this thing out of Saturn's Trojan, that thing will either gain or lose energy, but then
Yeah.
something else will balance that out. Like there's no, it's not like a collision
Yeah.
where energy is like converted into waste heat. It's like
Yeah.
gravity. It's like if this thing goes to a lower energy orbit, something else is going to a higher energy orbit. So,
Mhm. Yeah.
Pretty cool.
Yeah. I was also kind of thinking that I don't know if there's any connection with the Saturnian irregulars. I know there's a lot of Jupiter irregulars, and there are definitely some Saturnian
There's
irregulars,
a
and
there's a
those are
gajillion of them.
captured. Yeah, and
Right.
those are they're captured. So I don't know if there's any kind of like dynamical connection there that would be interesting. Because I'm pretty sure that we have or are going to have some JWST spectra of the Saturnian irregulars. We definitely have the
Oh,
Jovian irregulars. I don't think they're published yet, though. Um,
well,
but we have at least some information on them.
Cassini did a flyby of Phoebe, which is one of the
Yeah,
it's a big captured moon of Saturn. It looks, the pictures photographically it looks like an asteroid, it looks like a cratered thing, but spectroscopically, apparently, it looks like it's probably a captured Kuiper Belt object.
right.
Um, so, well, since we're talking about Trojans and you're on the Lucy mission, can
Yes.
you give us an update on the mission?
There's not too much to update on. I think we're gonna have another Earth gravity assist in like maybe a month or two, or maybe in November. It will, well, I can't
Well,
remember. But
That is a month
I
or
know, yeah.
two.
But yeah, there'll be another Earth gravity assist coming up in a little bit. It's not going to be as big of a showing, I guess. You probably won't see it in the news much because I don't think we're going to turn on all of the instruments this time.
Okay.
Last time we did an Earth gravity assist, we did some observations of the moon. Because there have already been a lot of observations of the moon, where we can use it to calibrate the cameras with the spectrometers and all of those things. We already have all of those data, so I don't think most of the instruments are going to be turned on. This is just going to be a purely like gravity assist to get us out there.
December
And then
13th is the answer.
December
December
13th.
13th. Yeah.
Okay, cool. I'm glad
Cool.
that my intuition was correct because I didn't actually know
That's
when
a
it was.
Friday, Friday, December
Oh,
13th.
oh
Uh,
no. It
and,
should be visible with maybe
but it'll
binoculars.
be moving so quickly.
It'll be pretty fast.
Yeah. 350-kilometer altitude, which is very close.
Yeah.
That's a lower altitude than the International Space Station.
Oh, I didn't realize it was going to get that close.
Yeah.
Oh, that's pretty
I
cool.
think that's right. I think the ISS, let me just double check that.
Okay,
Um,
while you're double checking that, I can say that after the Earth gravity assist in December, December 13th, then in March, we're going to fly past the second main belt asteroid on our tour called Donald Johanson. Um,
right.
and yeah, that'll be another kind of engineering test. The orientation of the asteroid with the spacecraft, the direction that it's flying by, and the angle it makes with the sun is a little bit different. And so it'll be a better test of certain um, engineering, like turny things that are on the spacecraft. It'll be a good test of that.
And then
Um,
that's the last thing that happens before it gets to its first Trojan asteroid
Correct.
in 2027.
Yeah.
And then
Yeah.
it does three in 2027, two in 2028. Oh my gosh, this is the part that I
It's
forget about that's so
it's
wild
like
about the orbit of
it's
this.
yeah,
It
it's super quick.
then it comes back to the Earth
Yep.
on December 26, 2030 to get
Mm-hmm.
a gravity assist to shift it over to the other family of Trojans, right?
To the other
That's what's so
swarm. Yeah.
wild because
Yeah.
it goes by a half a dozen or so in one swarm, some of which are binaries, so it's a twofer on those.
Yeah. There
Then
it's
it comes,
four systems, we can call it, four like target systems. So some of them, yeah, have
yeah,
satellites. But
yeah,
yeah.
and then it comes back to the Earth, and then it goes zipping out and goes. So the first group are in the what's called the L4, and then the last one in 2033 is in the L5 group. So very cool mission. So
Mm-hmm.
we're looking forward to regular updates from you. But So next up for Lucy is Earth flyby December 13th. It is closer than the International Space Station to the surface of the Earth, by the way. Then a few
Cool.
months later, a flyby of Donald Johanson at a distance of about 900 kilometers. Then 2 years after that, we get out to the Trojans. So that'll be cool. So I do have
Mhm.
an actual trivia that you may not know the answer to that I think is pretty interesting. It's more interesting
Okay.
than the other one.
Okay.
So we've been talking about Trojan asteroids. There are about, well, the pre-trivia, how many known Trojan asteroids are there? Do you know this
For
number?
It's like
For Jupiter, yeah.
known like 10,000.
That's exactly, I mean, exactly. That's right. It's, I mean, 10,000 plus or
Yeah,
minus whatever, a
but
few
it like
percent.
it grows like every
We're
day, the
discovering new
number.
ones all the time, right?
Yeah.
So the actual trivia question is based on, observational, all these effects and how dark they are and, and how rapidly we're discovering them. What is the estimated total number of Jovian Trojan asteroids larger than 1 kilometer? And I'm going to give you a hint or a point of reference. In the main belt of asteroids, which is the asteroid belt in between the orbits of Mars and Jupiter, the number of asteroids larger than 1 kilometer is estimated to be between 1.1 and 1.9 million.
Right. Okay.
So and then and now at Jupiter, we have observed 10,000 or so, as you said.
Hmm.
How many do we think total there are of that size, 1 kilometer or larger, in the L4 and the L5 regions of Jupiter combined?
I think it's about 1 million.
You are nailing it.
Yeah, I knew that one too.
Yeah. No, but it's really cool. There's like
Yeah, there's
almost
like,
as many asteroids, Trojan asteroids, as there are main belt asteroids.
right?
Yeah.
It's
This is
amazing.
this is wild. Yeah. And they're far and they're
They're
dark.
far, they're very dark, and they're kind of cold.
Yeah.
So,
Yeah. So
yeah.
hard to see, but it's a whole new world. It's a whole new realm of the solar system to explore. So pretty
Yes.
cool. Well, while it may have felt like counting Trojan asteroids, it was just another episode of Walkabout the Galaxy.
Be sure to follow us on Instagram and YouTube. Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger.
Extra sound effects are supplied by Audrey's dog,
Benicio.
Benicio, of course.
Benicio del
Uh,
Toro.
Thanks to our listeners in Peterborough, England, and around the world. I'm Josh Caldwell.
And I'm Audrey Martin. We are two Astro Quarks signing off until the next episode of Walkabout the Galaxy.
Woohoo!
I hope all of his whining and gruffing made it.